Alright, so we are going to look at the Aqueous lead nitrate. It's mixed with an aqueous sodium iodide. And we're going to look at, firstly, the chemical reaction, looking at the molecular equation, the ionic equation, and the net ionic equation. So firstly, let's start with our two compounds, which is our lead nitrate and our sodium iodide. Now, at the moment, do we know that these are balanced? We don't actually know whether they are or not, so let's work out if they are. So lead has a positive charge of 2 and nitrate has a negative charge of 1, which means that this is unbalanced, so we need to put a 2 here to indicate that there are 2 lots to balance that compound. Alright, now let's have a look at our sodium iodide. So sodium has a charge of +1 and our iodide has a charge of -1. So that compound is balanced. And then we're going to look at what are we actually going to form in this chemical reaction. So we know that our positive ions, so our cations, are going to react with our anions. So we've got lead that's going to react with our iodide, and we've got sodium that is going to react with our nitrate. Now we won't worry about numbers at the moment. We're just firstly going to balance these compounds to make sure that they are correctly represented. So sodium has a charge of +1 and nitrate has a charge of -1, so that is correctly balanced. And our sodium has a charge of 2+ and our iodide has a charge of -1, so we need to make 2 of those to make sure that that compound is correctly balanced. Alright, so now we need to balance our chemical equation. So we can see over on the right hand side here that we've got 2 iodide molecules, and we need to then balance that by putting a 2 in front of this. Now that means that we have actually unbalanced the equation on this side, so we need to put a 2 over here. Now, does everything else add up? We've got 6 there, 2 there, 2 there, 2 sodium, 2 iodide, 1 lead. So that's our balanced chemical reaction. Okay, now we need to work on our our ionic equation. And before we go any further in our ionic equation, we need to work out what's actually going to precipitate out of this interaction between the lead nitrate and the sodium iodide. So these are all aqueous. Now, which of these is going to be soluble and which one is going to be insoluble? Anything that's got salt in it will always be soluble in water, therefore this is an aqueous solution, which means that our lead iodide is our precipitant. Okay, now we can move on to our ionic equation. So what we need to do is we need to break down our compounds into their individual ionic components. So we'll start with our lead. And now we need to include the charges because this is about, they are all ions. So lead has a charge of 2+, and then we're just bringing this 2 of the nitrate to the front. Nitrate has a charge of -1. And then breaking apart this sodium iodide into its 2 ionic counterparts. And then moving on to the other side of the equation. Now, we are only breaking down the compounds into their ionic components if it's in aqueous solution. We don't break down our solid because that's what's precipitating out. So that stays as lead iodide, which is our solid. So these are all occurring, these are all aqueous. And it's a good idea to keep these as aqueous, so because we'll need that later. And then we've got our sodium, the charge of +1, and our nitrate. And this is aqueous, and this is aqueous. All right, so to move on to the next stage, we need to work out what the net ionic equation is. So that is which of these ions are actually interacting to create the chemical reaction that we're seeing, and which of them are spectator ions. So anything that occurs on both sides of the chemical equation in the same state can be cancelled out. So our nitrate occurs on the same side in both the same state, so it can be cancelled out. And our sodium also occurs on the same state on both sides of the equation. So now we can write out our net ionic equation. And that is our lead, which is in aqueous solution, plus our iodide, which is also in aqueous solution, which then turns or reacts and forms our lead iodide. Okay, and that is our net ionic equation. Now, to identify our spectator ions, those are the ions that did not do any chemistry. They did not react in this reaction. So that's our nitrate and our sodium.